Hello students, because of some personal reason I am not able to share the live lecture with you. That is why I am just sending this recorded video. So in the last lecture we have seen about the sensors and its requirement, what is sensor, how it works, which are the different types of sensor, what are the characteristics of the sensors. We have seen all those things. Along with that we have seen that LM35 is one of the temperature sensor, and we have seen its diagram, its working, and the different applications of LM35. In this lecture what we are going to do, we are going to study the light dependent resistance, that is LDR. Abbreviation of light dependent resistor is LDR. It is often called by that name only, LDR. Okay, so a light dependent resistor is a component whose resistance vary with the intensity of light falling upon its resistive track. Now the very first thing is, what is resistor? Resistor is a device which will oppose the flow of current. Okay, so in case of light dependent resistance, the working is going to remain same, it is going to oppose the flow of current. But whenever light fall on the resistive track on the surface of the LDR, okay, the total darkness of LDR has a resistance of several mega ohm and a resistance of less than 100 ohms in very bright light. Now, if we put that resistance, sorry, LDR, in a very dark situation, okay, in dark situation, the resistance is very high, okay, and if we put that resistor in a bright light, in that case the resistance is very low. So remember this thing, in dark light resistance is always high, in bright light resistance is always low. Okay, now as we know, it is a simple resistor, but whenever light fall on this resistor, its resistivity changes. Now we'll think which material is used for making or construction of this LDR. So cadmium sulfide is used to make the resistive track, and it is clearly visible through the transparent cover. Okay, so as you can see this diagram, in this diagram that tracks, okay, so these crisscross lines represents the cadmium sulfide track. Okay, and this covered portion, this circular portion is a transparent, we can easily see those lines. Okay, and whenever light falls on these lines, what happens? The resistance changes. Okay, so symbol of the LDR is represented like this. So this is general resistor. When light falls on it, it will change its resistivity. Next point is, LDR suffers from its relative slow response time. So basically its response time is very less. Now what is response time? Whenever we apply input, it will take some time to produce the output. Now in this case, whenever we strike light on the cadmium sulfide track, it will take some time to react on it. Okay, so it will take some time to change its resistance. All right, after that, the resistance rises from the illumination provided by 60-watt lamp at a distance of 1 meter to that in total darkness about 75 milliseconds. The reverse takes up to 350 milliseconds. So LDR connected in series with the resistor across the supply rails which from a voltage dividing chain to make a light sensing unit. Now what are these 2 points? If you want to make a circuit which will control the light, okay, so maybe the light present inside your home or street light control or any other application where you need to control the light, so in that case you can use this LDR in series with the another resistor. So if we connect two resistors in series and if we take output at the middle, then what is it called as? It is called as a voltage divider. Okay, so if we just do that, it will look like this. See this, this is your positive voltage supply. After that there is a resistance, normal resistor, and after that there we have a LDR. Now how to identify normal resistance and LDR? So wherever there is LDR, there will be a arrow direction which is coming to the resistor. Okay, why arrow? Because light falls on the resistor and light will be indicated by the arrows. Okay, so if we connect this LDR to the ground, okay, we know that now in this case this resistor is connected to the supply and this LDR is connected to the ground. So in this case the light, if light falls from dark to light, okay, and in the opposite case here LDR is connected to the power supply and another resistor is connected to the 0 volt. 0 volt is what? It is a ground connection. So here light intensity will change from dark to light. So at this point, you are going to get your output voltage. We will see in detail how that output voltage will be taken at the middle of these two resistors. All right. So in case of arrangement shown in the figure, which we have just seen, in first figure, when the LDR is in the darkness, it will have a very high resistance. I have already told you, whenever it is kept in the dark, its resistance is high. Whenever it is kept in bright light, its resistance is low. So what we have seen, uh, it will have a very high resistance, and most of the supply voltage is dropped across it. What is the meaning high resistance? Whenever we say the resistance is high, what does that mean? The large value of resistor is there, and because of that large value, all the voltage will drop across the same resistor. Okay, that is why the output signal will be high. After that, in bright light, the resistance of LDR becomes low. Now we know that in bright light, the resistance becomes very low. The opposition is low, and the most of the supply voltage is drop across the resistor. In this case, the output signal voltage will be low. Okay, so there are two cases. In first case, we have put our LDR in the dark light. So in dark light, it offers a very high resistance. As it offers a very high resistance, you will get a output high. Okay, and in case of bright light, in bright light its resistance is very low. As resistance is low, you will get your output voltage low. Okay, after that, a falling edge at the output is produced due to the sudden change from darkness to brightness. Now this, we know ki whenever you have bright light, resistance is like whenever you have dark light, the resistance is high. But why that high to low transition is there in here? Why there is a dark to light transition is there? Okay, because suddenly we are going to put that resistor from one light condition to another light condition. Because of that sudden change, there will be a that spike or falling edge, you can just say. So in figure 7, second figure basically, a generation of rising edge at the output of the arrangements can be observed when there is a change from darkness to bright light. So in this case we have a falling edge from dark to light. In this case we have falling edge again, but it is light to dark, and all the two edges are there because of this sudden transition from light intensity. Okay, so that is all about the LDR. Okay, it is light dependent resistance. Now the applications which are not listed here, but the applications of LDR are, it can be used in controlling light intensity, no matter which position is, like in office, in home, in streets, you can just control the intensity of light wherever you are. Okay, with the help of LDR you can just control the light intensity. So you can just write applications along with that. Okay, so next sensor is your passive infrared sensor. It is oftenly called as a PIR sensor. So in case of PIR sensor, what is it? Passive infrared. So I'll explain the construction and working of this PIR sensor. Now, first of all, before studying this diagram, try to understand the concepts behind this. A passive infrared sensor detects the heat energy. Okay, what this sensor is going to do? It is going to detect the heat energy. If there is any warm object close to the sensor will sense that object. Okay, for example, human beings. Okay, why human beings are like heat energy? Because we have warm blood inside our body, and that is why this sensor has that ability to change the to not change to sense the object which is nearby to it, who is having heat energy inside that. Okay, the basic function of the PIR sensor is, we can say that it detects the heat energy. PIR sends invisible infrared beams that respond to the temperature differences. Now what is going to happen? Now see this. If this is your PIR sensor, this entire thing is nothing but your PIR sensor. It continuously sends infrared rays out of it. Okay, it continuously sends the infrared out of the sensor. Now in the range of those infrared, if any warm object comes, then what is going to happen? That infrared is going to strike back to the sensor. For an example, as you can see, this light infrared beam is hitting this person. As we know, the humans are warm blooded animals, or like any other animal, cat, dog, any animal which comes in the contact with these rays, what will happen? The ray will strike on a body, it will detect the temperature difference, and it will go back to the sensor. Okay, and whenever sensor receives some return, or like return, we can say that return waves or rays, the sensor will indicate there is some person. Okay, so it's as simple as that. After that, when a warmer object such as human body crosses at least two beams, the temperature difference between the person and the background is detected and sensor respond. Now, only this single beam is if the only single beam is hitting the human body, then it is not going to detect. At least two beams should be strike on the human body and it should get reflect back to the sensor. Then and then only the sensor can detect there is a object. Okay, now there is a difference. Okay, so this wave or this ray is hitting the surface and going back to the sensor. Now there is no temperature difference, correct? But these two rays are hitting human body. Whenever that rays hit to the human body, there is another temperature than surrounding, correct? So these two rays will detect the change in temperature and that will indicate to the sensor, and according to that your sensor will respond. Okay, if the space is empty or there is no one in the range of sensor, obviously it will not respond, correct? So whatever is the range, suppose in this diagram, so this is what is the range of the sensor. Okay, so one person is standing over here. What is going to happen? Sensor is not going to sense that person, correct? Why? Because this person is not in the range of sensor, right? After that, more the number of beams, more the sensor becomes sensitive. Now, what is going to happen? Probably because of only two rays, there can be a chances of mistake. Okay, as multiple beams strike on the person, it will reflect back to the sensor with the temperature change, correct? And if we have multiple temperature change reading, then we can say the accuracy of sensor is very high. After that, the sensor respond well to cross motion than the object which is approaching towards the sensor. Now there is another thing. The beam of the sensor is reflecting like this, like this, like this. If some person crosses like this, then and then only the sensor can detect the person. Okay, otherwise what is going to happen? Suppose the person is moving from this direction to this direction. Okay, the sense a person can easily pass through the beams. Okay, without touching the beam, person can easily pass. So that is why they have said the sensor responds well to the cross motion. This is the original direction of the rays and this is the cross motion to the rays, and that is why in that case only sensor can detect a very accurate reading. In case of parallel motion, sensor will not respond. Okay, its basic requirement is a line of sight and does not read through any material. Now what is the requirement of this PIR sensor? It will work to the line of sight distance only. Now what is line of sight? Without any interrupt, I can see at particular distance. Okay, and that visible distance is called as a line of sight distance. Okay, so easily you can just sit in your home and through the window or through the door you can be able to see the distance which are like objects which are far away from you. But if there is any wall, if your door is closed, if your window is closed, then in that case you are not able to see the things. Okay, so if whenever the door is open and at the point where you can just see, that is nothing but your line of sight distance. Hence, it is not suitable for the spaces having barrier in between. For example, office with high cuboid wall. So that is why we cannot use this sensor inside the office or inside the home. Correct? Why? Because in home we have multiple walls, and through the walls we cannot see. That is why this sensor is also not able to reach to this person who is standing behind the wall. Right? So for a short distance, it is not usable. Okay, the PIR sensor can work up to a range 40 meters, proves their stability for places like enclosed offices, high ceiling warehouses, car parking, etc. Now car parking is very simple example. Almost every one of you have seen the car parking. Okay, in car parking there is no wall, right? There is a empty plot, and on that empty plot I can see to the end of the plot, correct? So as I can see to the end, till the end, the sensor is also able to sense the object which is at the end position of the plot also, correct? So that is why in the open spaces like enclosed office, high ceiling warehouses and car parking, you can use this PIR sensor. Okay, and the last thing is that it is not suitable for extremely warm environment, as it fails there to distinguish between the human body temperature and background. Suppose if you are living in a desert area where temperature is very high, in that case the sensor will be able to fail to detect the change between surrounding and human body. Okay, right now wherever we are sitting, there is a difference between environment around us and environment or temperature inside our body. Okay, so the body temperature is slightly higher than the surrounding temperature, but if you are in a desert area, then in that case surrounding temperature is also high and your body temperature is also high. So in such cases the sensor may get fail to detect the temperature difference between background as well as human body. Okay, so this is all about your PIR sensor. PIR stands for passive infrared, and what it does, it will detect the heated object which are come in the range of the sensor. Okay, I hope these two sensors are clear to you. The next sensors we'll discuss in a live lecture.